All right. These are force versus time, velocity versus time system graphs, and I love it. It's this big Sudoku where we're going to have the momentum of one object, the momentum of another object. They're going to feel some sort of force or some impulse, and that's going to change their momentum, and we can fill in all these graphs, and all the numbers are going to work together like it's some big Sudoku puzzle. That's why I love these. They feel like a puzzle. So let's read the scenario. I'm going to circle anything that I think is going to be important. Let's read this scenario together, team. A 3 kilogram cart, red cart, moving at 5 meters per second, collides inelastically with a 2 kilogram cart at rest. I'm immediately going to write 0 meters per second because that's what at rest means. The collision lasted for 2 seconds and the max force was not recorded. So I'm going to put a little question mark for max force not being recorded. Now, complete the velocity versus mass graphs and mass and force versus time graphs below. And we're going to calculate the areas. So it's not so bad. We're going to just fill in everything we know. The red cart was 3 kilograms according to the prompt, and it was moving at 5 meters per second. Is that right? There we go. 5 meters per second. And I'm just going to immediately calculate the area. That's 15 kilograms meters per second of momentum. The 2 kilogram cart, it's at rest. So I'm just going to draw a little flat line and write a 0. It has no momentum. And then it says the collision lasted for 2 seconds. Now we're down here during the collision. So I'm going to draw a little line on 2 seconds here. We don't know how much force yet, but we'll find that out. So the force on each car, they collide with each other, so it lasts the same amount of time. And now we're on our own, and we've got to fill in the velocity versus mass graph after the collision. So let's do that really quick. Well, we know that the red cart has a mass of 3 kilograms and the blue cart has a mass of 2 kilograms. They stick together. We're going to treat it as one object, so we know that they have a mass of 5. Now, we know that the total momentum before the collision are those two numbers added together. So the total momentum is 15. So we need an area down here of 15, positive 15. And how can we create a box that has 15 squares in it? Well, the carts must be moving at 3 meters per second. Good. Now, here's this new idea. Here's a new idea. We are looking at the objects as a system in this graph here, but we can actually see both carts individually if we look closely, specifically thinking about the mass. So how much mass did the red cart have? It had 3 kilograms. And if I go to my 3 kilogram line, I'm going to just draw. Well, here, let me go to the 3 kilogram here. Here's how big my red cart is. It's 3 kilograms. It's moving at 3 meters per second. So I'm just going to, inside that box, I'm going to draw my red cart. There's the bell. And then with my blue cart, that was 2 kilograms. That's the remaining mass. So I'm going to fill that in here. And now I can solve. So how much did the momentum change? Well, we started at 15 for the red cart. We ended up with 9. And that's a change of 6. It went down. It lost 6 kilograms meters per second of momentum. So this graph needs to show a impulse of 6 kilograms meters per second. So, and remember, we have a triangle shape for these graphs. It has to change by 6. Boom. So we can start to fill in what we know. If I calculate the area, remember it's 1/2 times the base, which in this case is 2, times the height, which is -6. I end up with -6. Good. Now, the force acting on the other cart, it's going to be the same thing. It feels a force in the positive direction because they are force pairs. And this is a impulse of 6, or there's a change in momentum for the blue cart of 6 kilograms meters per second. And that makes sense to me because if we start with 0, we add 6, we get 6. Now, if we started with the red with 15, subtract 6, we get 9. And look at that. It's this beautiful Sudoku puzzle. It didn't give me all the information, but I used the law of conservation of momentum so that I knew that the total momentum before equaled the total momentum afterwards. And then I started solving for what I didn't know. That's how you do these.